It is shocking news. The James Webb Space Telescope has discovered evidence that the universe has stopped expanding. The space industry is at a dramatic turning point. Does this possibly mean that the universe will soon come to a complete standstill and that we are on the verge of a big rip or big freeze, in which the entire universe tears apart or suddenly freezes? Scientists around the world are alarmed and are examining the implications of these latest discoveries for our current cosmological models. We must now ask ourselves fundamental questions about the nature of space and time. The idea of the expansion of the universe will soon be celebrating its 100th birthday. In the 1920s, in the USA, an astronomer named Edwin Hubble was researching the then brand-new galaxies that had just been discovered. Imagine. That was the time when researchers first realized that our Milky Way was not the entire universe, but just one galaxy among many. First, the Andromeda Nebula appeared. Then, more and more galaxies opened up before Hubble's eyes, and the researcher was one of the first people on this planet to realize just how big the universe really is. Hubble was not only confronted with this shock, but he also saw something that astonished him even more. In particular, the galaxies far away from us seemed to be moving away from us. How could this be explained? Hubble measured the movements and distances of the galaxies using the redshift of light. The further away the light source is, the more the color spectrum of the light is shifted to reddish. Hubble observed galaxies, their directions of movement, and estimated their speeds. In doing so, the researcher noticed a linear quantity that later became known as the Hubble constant. This states that distant galaxies move away from us in proportion to their distance. Hubble published his groundbreaking discovery in 1929 and later combined his discovery with the theory of a Belgian priest and physicist who had been researching the newly discovered galaxies at around the same time as Hubble. Georges Lemaitre had already suggested in 1927 that the universe was expanding from an original state of high density and temperature. This concept later became known as the Big Bang Theory. Lemaitre's work was largely based on the field equations of Albert Einstein's general theory of relativity, which predicted that the universe could be dynamic and would either expand or contract. Together with Hubble's discovery, Lemaitre's idea and Einstein's equations of relativity became the foundations of our cosmology. Little has changed in these foundations for almost 100 years, until the James Webb Space Telescope entered the stage of science. This revolutionary new telescope is now showing us a series of phenomena that are no longer compatible with the current theories of standard cosmology. While it's now common knowledge that physics is facing a huge crisis as a result of Webb's discoveries, it is less well known that these problems and challenges are not new. In fact, researchers have long discovered that the universe does not behave quite as predicted by calculations, and they have even discovered that for some mysterious reason, it has stopped expanding, at least as far as our old ideas of physics are concerned. Is our universe a whirlpool? It is an exciting time full of news, upheaval, and debate among baffled scientists. One of the most important problems in assessing the current situation of our cosmos is the question of dark matter and dark energy. Observations of the rotation curves of galaxies and the cosmic microwave background radiation showed that the visible matter in the universe is not sufficient to explain the observed gravitational effects. This led to the hypothesis of dark matter, an invisible substance that makes up about 27% of the total matter-energy density of the universe. But what if our estimates of the dynamics of our universe were completely wrong? Webb's discoveries provide evidence that we have so far completely misjudged fundamental aspects of the universe. This may start with the rotation of galaxies and certainly does not end with the expansion of the universe. Where these phenomena do not appear, the existence of dark matter and energy would not be necessary either. Another significant problem emerged in the late 1990s when researchers discovered that the expansion of the universe is accelerating. This discovery underpinned the hypothesis of dark energy, which supposedly drives the expansion and could be responsible for fluctuations within the constants. Again, we may have made a huge mistake here. If our previous measurement methods were wrong or based on completely false assumptions, there may be neither a linear expansion nor a space in which the universe is expanding, as Hubble and Lemaitre suggested. In fact, Some calculations show that our universe could be much more like a giant whirlpool fed by different sources. Imagine how energy and the building blocks of matter are channeled into this space through multiple sources. In some places, this would lead to more turbulence, and in others, the dynamics would be smoother, just like in a whirlpool whose jets are far apart. The idea of the expansion of the universe would then cease to exist. Instead, researchers would have to admit that their conclusions are based on observational errors. This model of the universe is currently not accepted because further key evidence is lacking. However, recent observations from the James Webb Space Telescope are pushing these assumptions forward again, and slowly, scientists are having to face unpleasant truths. Are we on the verge of the Big Rip, the Big Crunch, or the Big Freeze? It sounds scary because researchers have determined that an expanding universe would have to end in a gruesome scenario at some point. Imagine the universe keeps expanding and expanding until it becomes brittle and cracks. Here we are at the idea of the Big Rip, a hypothetical consideration of where the expansion of the universe will lead. Unfortunately, the Big Crunch is not a much more optimistic variant, as the universe will eventually collapse when exhausted. If we follow this hypothesis, the expansion stops at a certain point, reverses, and all the splendor of the universe collapses. Let us also consider the Big Freeze, where the universe has used up all its energy at some point and is frozen in a kind of shock state. In all these cases, the expansion stops abruptly, and there is a kind of collapse or shock state. It's really scary because researchers have discovered regions in the universe that point to an imminent end to the expansion. Are we on the verge of the collapse of the universe? The latest data suggests that the structure of the early universe was much more complex than previously thought, and that there may be unknown physical processes influencing local expansion rates. This could lead to fundamental changes in our understanding of cosmological principles. The concepts of dark energy and dark matter may have to be completely revised, and ideas such as a universe that is eternal and fed by many sources are gaining momentum again. The idea of eternal inflation stems from the work of physicist Alan Guth, who proposed the original theory of cosmic inflation in the early 1980s. This theory was later developed further by Andre Linde, who introduced the concept of eternal inflation. The cosmic inflation theory states that the universe underwent a phase of exponentially rapid expansion in the very first moments after the Big Bang. Linde extended this theory by showing that in an inflationary universe, certain regions can continue to grow exponentially while other areas cease their inflation and undergo normal expansion. This leads to the notion of a multiverse in which new bubble universes are constantly being created, each of which may have its own physical properties. In Linde's model of eternal inflation, there is no definite beginning or end to the universe. Instead, the process of bubble formation continues endlessly, indicating an eternally existing multiverse. Has the universe really come to a standstill? Now it may sound strange, but it's true. Our universe has, in a sense, come to a standstill. The expansion, as we knew it, or as we thought we knew it, has definitely come to a temporary standstill. All dynamics in the universe are at a standstill at the moment because they were nothing more than concepts in our brains or theories on paper. We are currently experiencing a big freeze, a shock wave that has brought our science to a standstill and paralyzed it. Webb's images and measurement results are putting the space industry and science in a state of uncertainty. All images that show the young universe or that refer to large-scale structures speak against the old concepts. The flow of new findings does not stop. Webb continues to provide yet another picture, new measurement data that no longer fit the complete picture of the universe as scientists have drawn it for almost a century is currently collapsing, as envisioned by the idea of the Big Crunch. Today, more than ever before, the question arises as to whether all these theories are essentially wrong and whether we may be living in a universe that is far more dynamic and changeable than we thought. For a long time, researchers have constructed a house of cards and built theories on shaky foundations. Almost our entire cosmology is based on dark matter and dark energy, which, in the end, could never be proven. Alternative approaches, such as the idea of tired light, the Mond theory, the theory of holographic gravity, or the theory of the variable speed of light, show that the universe can also be explained on the basis of completely different parameters. The idea of tired light goes back to the Swiss Fritz Zwicky in the 1920s. He postulated that the light from distant galaxies loses energy over large distances and therefore appears redshifted. This theory was an alternative explanation for the expansion of the universe. Very similar is the theory of the variable speed of light, which states that the physical properties of light may have been different billions of years ago than they are today. If this is true, then our entire cosmic worldview is not correct. Basically, Mond postulates something similar. The modified Newtonian dynamics theory postulates that gravity is not a constant quantity either, but has been subject to changes over the course of time. Holographic gravity is even more exciting. This is because Eric Verland's idea proposes that gravity is not a fundamental force, but results from the basic principles of quantum information and thermodynamics. In plain language, this would mean that our universe functions like a giant hologram in which we ourselves are possibly the co-creators of the physical quantities that we can observe. If we combine quantum mechanics with a material universe, it could even be that we ourselves create the problems that our natural science is currently facing. Thank you for watching the video. See you soon next video. Thank you so much.